type of a coordinate proof. Same one as we've done before, where we've got triangle KID. It's got vertices with these coordinates. We're going to prove it's an isosceles triangle. Now would be a great time to pause this video and actually complete this proof. Don't worry, I'll wait for you. Okay, so now we graph this triangle. And as we're looking at it, it kind of looks to me like side KI and side KD. I'm sorry, KI and ID. These two sides here look like KI and ID are the equal sides. So I'm going to do those distances and show that they're the same. So let's see, if I do the distance of side KI, I know I got to do my distance formula. You can do Pythagorean theorem if you want. So I'm doing -9 minus 1, squaring that. And then doing 8 minus 3, squaring that. And I think when I do that, let's see, I get -10 that I have to square. And then I'm squaring 5. So that's going to equal 100 plus 5, the square root of 125. Okay. And let's now take the distance of side ID. Get another distance formula. Here we go from I to D. Maybe we'll do like -1 minus 1 and square that. And then we'll do, say, 8 subtract -3 and square that. And let's see what happens when we do those. We get -2 that we're going to square. And it looks like we get 11 that we're going to square. When you square -2, you get +4. 11 squared is 121. And check this out. They both equal 125. So now I'm going to write my concluding statement here. So my concluding statement is going to be something like, hey, the sides are equal, so the triangle is isosceles. So let's see. Since KI is equal to DI, triangle KID is isosceles. We're going to write at our conclusion. Sounds good to me. What I actually want to do, just because I'm thinking ahead a little bit, if you don't mind, I'm going to grab all these things and I'm just going to slide them all over to the right a little bit. There we go. I'm going to need a little bit of room, and let's get that radical 125 over there too. Great. Okay, so let's keep going. So what's going to happen now is we're going to try to state the coordinates of point N. So that's going to make kind a parallelogram. So I'm going to go back to my grid for a second and think about that. So I'm going to make this into a parallelogram kind. So it's got to go KI, whoops, hold on. Let's get a different color there. It's got to go like KI, N has got to be somewhere over there, and D is going to be there. So the question is, though, where is N? Well, let's figure out how to find it. There you go, just leave that in there. So let's talk about how to find that. Well, if you think about some things about parallelograms, you know, for example, that the opposite sides are congruent, or the opposite sides are parallel. So that's going to be a big help for us. So what I'm thinking is, if I have to go from point K to point I, I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. And I'm going to go up 1, 2, 3, 4, 5. That's kind of how I would find the distance for Ki, like a Pythagorean theorem. You could also think of it like the slope is like the rise over the run. So either way, I'm going to the right 10 and I'm going up 5. So I should have to do the same thing from point D. Go to the right 10 and go up 1, 2, 3, 4, 5. Okay, now that stuff's annoying me there. Let me get rid of that altogether. Here's my 5th point. So this is where point N is going to be. And this is going to make my parallelogram. And as I look at that, it does kind of look like a parallelogram now. So if I'm looking to state the coordinates of point N, it looks like point N is at 9, 2. So when you ask state those coordinates, let's write down that point N is at 9, 2. And then I'm asked to do something else here. Okay, so now we found that it was a parallelogram. Let's justify using some coordinate geometry. So if you want to prove things are a parallelogram, maybe what you can do is you can do some slopes of the sides. You also know that in a parallelogram, the opposite sides are congruent. So maybe I'll do the distances of a couple sides. You can do whatever you like to do. I think I'm going to go with some slopes though, just to be a little bit different. So let's find some slopes now. So the slope of side ki, if I do my slope formula here, I'm going to do 8 minus 3 over 1 minus negative 9, and that's going to give me 5 over 10. And let's see what the slope of side ND is. I got point N there, point D from before. Maybe I'll do like negative 3 minus 2, and then I'll do negative 1 minus 9, and sure enough, that gives me negative 5 over negative 10, which is 5 over 10. Let's do some other slopes. Let's do the slope of side IN. If I do that slope formula, yes, IN, let's do, let's go like 8 minus 2 over 1 minus 9, and that's going to give me 6 over negative 8. And if I do the slope now of side KD, let's do negative 3 minus 3 over negative 1 minus negative 9, which is negative 1 plus 9. So I get negative 6 over 8. Notice that those slopes are all equal to each other, or at least IN and KD have slopes that are equal. So let's write our big conclusion now. What we've seen is that the opposite sides have slopes that are equal. So the opposite sides of kind have slopes that are equal. And what does it mean if slopes are equal? Well, it means that sides are parallel. So the opposite sides are parallel. Great. And wrap it up into one final thing. So so kind is a parallelogram. So in a proof like this, what you have to do is you have to first prove one part and then use that to prove another part.